Hello, I'm Todd Spatafor, and this is another Spectacular Thing. 25 years ago, I wrote some code that looked like this. It was VB script written in Visual InterDev on Windows 2000. What this code does was nothing short of amazing to me. It took the server time and displayed it on the web page. Simple by today's standards, but at the time I'd been writing static HTML sites. I took that first tiny step in a large world where I could gather data from a much larger pool of information. Today we are going to take a similar first step into web development, only we are going to use Go as our language. First we are going to build a simple web server, then we are going to handle requests and responses, and finally we are going to look at middleware and custom handlers to make our code a little bit cleaner. So sit back and relax or fire up your editor of choice because this is Go Programming Unleashed. Start your web development journey. The start of the web journey has to be in the web server. For this project, we don't need to spin up IIS or a Docker container with Nginx or Apache. No, we're going to use net HTTP package from the Go standard library. Being a part of the standard library means the core team maintains it, it's very stable, and it's optimized for performance. The net HTTP package provides both HTTP server and client implementations, allowing you to build web servers as well as make requests to other services. It also provides a simple API that abstracts the complexities of HTTP. As we'll see later, this package also supports middleware patterns. Overall, the net HTTP package provides a powerful foundation for building applications in Go, combining simplicity, performance, and flexibility. To start this journey, let's print out the current server time, just like I did in VB all those years ago. Just like we do with any Go project, we start off with the package main declaration, as well as a few imports from the standard library. Here we're importing format, net HTTP, and time, like this. Next, let's write a function that will handle the request. This function takes a response writer and a pointer to the request. The response writer is our conduit to the browser. We can write strings to this response writer and they'll appear on the browser. The pointer to request gives us all of the information about the HTTP request. Together this satisfies the contract for an HTTP handle function. Next we get the current time and place it in the variable current time according to RFC 1123 standard, which prints out the current day of the week, the day of the month, year, time, and time zone, as we will see when we run this program. Finally we get to the main function. This is the heart of the server. First we register the function that will handle the root URL path. Then we print a line on the console to remind us of what port we're listening on, and next we start an HTTP server on port 3000 and handle requests with the default server mux. What does that mean, to handle requests with the default server mux? And what is a mux? A mux is short for multiplexer. It is a component that routes incoming HTTP requests to their corresponding handler functions based on URL patterns or paths. The default serve mux is the default multiplexer. It is a simple way to set up basic routing without needing to create and configure your own multiplexer. It is ideal in this scenario because it is simple and we don't have a need for the advanced features like subroutines and middlewares. When we run this using the command go run main go and launch a web browser to port 3000 of localhost, we see this. Although it is a lot more code than my simple 7-line program from 25 years ago, it does a lot more than that program did. So here's the thing. Putting the current server time on the screen isn't exactly the coolest thing you can do, and I'm sure you didn't get the same excitement that I got 25 years ago. So let's make this a bit more interesting. What we just did is an HTTP GET request to the root of the web server. There are many verbs in the request like get, post, put, and delete. There are others, but they are for advanced uses. What an HTTP verb means is an action. I want to get a web page. I want to post data. I want to put an update to the data, and I want to delete that data. That is the kind of thing we're talking about here. Each of these can be used on a route, but they make more sense in a more robust set of routes. Let's look at that. In this example, we will look at using the request data to figure out what method or verb was used on a page. Let's switch to Visual Studio Code for this. In Visual Studio Code, using the REST client extension, we can create requests in an HTTP file and execute them against our server. First, open Visual Studio Code and open the extensions toolbar. Search for REST client and install it. Once it's installed, create a text file with the .http extension. Here I created a file called commands.http. I'm going to write 3 calls to the server. The first is a GET request, and when I execute it, you see that I get a response of 200 OK, and the text GET requests to the homepage. The second is a POST request, where I send some data to the server and I also get a 200 OK. In this case, I get the text POST request to the homepage appears. Finally, we have a PUT request with a change that should happen to our user, but when we execute it, we get a 405 method not allowed error, and the text method not allowed appears. This is because we didn't implement the PUT request. Okay, but this is still quite boring. Let's jazz it up a bit with query parameters in the GET method and read from form data that we send in the POST method. First, let's look at query parameters. Query parameters are the key value pairs that appear in URL after the question mark. They are separated with an ampersand and are written in the key equals value format. The key and value must be URL encoded. Let's say we want to get a particular person and that person's name is Joe. You would write your URL like this. On the server side, you would read the parameter like this. You can see that when we include the query string $name equals Joe, this query handler prints hello and the name. This isn't very good practice though, and we aren't checking the input string before putting it on the web page. Don't do that in production code. Since we are just learning, it's okay here for now. Now let's look at a POST request. The simplest POST request is a form submit. Here's how you would parse the form data. Now, if we craft an HTTP request like this, we also get a hello Joe message, but we got that name from the form data. Sometimes you want to act on a request either before or after the main handler. This would include such tasks as logging, authentication, and authorization. Or you want to modify the response in a consistent way with every request. Middleware allows you to add reusable functionality to the application without modifying the core logic of the handlers. Middleware is implemented using a chain of functions that wrap the HTTP handlers, each one taking an HTTP.handler as its input and returning an HTTP.handler as the output. This allows us to chain middlewares together, forming a pipeline through which requests pass. This might be better demonstrated with an example. This is a sample logging middleware. See how it takes in a handler and returns a handler? That's the pipeline or chain in action. This middleware logs each request method and URL path. Calling this is as simple as this main function. First, we wrap our main handler as a handler func. Note this is handler func. I've spent far too long troubleshooting problems all because I wrote handle func instead of handler func. This pattern allows you to add or remove middlewares easily. Middleware is used to augment or modify the request response cycle. How or when do you generate responses to requests? Well, we've been doing that for a while now. We just haven't given it a name. That name is handlers. Handlers focus on application-specific logic where middleware focuses on cross-cutting concerns like logging and authentication, etc. Middleware takes a handler and returns a handler, whereas a handler takes a response writer and a request and returns nothing. It processes the request and puts the answer in the response. It is simply implementing the handler interface. An example of a custom handler looks like this. Then to use it, you would have a main function similar to this. Instead of wrapping a function with HTTP handler func, we are specifying our own handler. We started this journey looking at the net HTTP standard library. We used it to recreate a page that displays the server time. Next, we looked at handling requests and responses, and finally followed by middleware and handlers. There's a lot left to learn, but we've come a long way. You have enough knowledge now to start working on your own web applications, but come back for the next video where we'll cover concurrency, third-party libraries, JSON, and error handling. Please subscribe and ring the bell so that you're notified when more videos come out. Thank you for watching. You can find me on Blue Sky, Threads, GitHub, and the web using Spectacularly as the name. See you in the next video.